All right, welcome everyone to this edition of vCluster Fridays. I'm your host, Scott McAllister. I'm a developer advocate here at Loft Labs, makers of vCluster. I'm joined today by folks from the CloudNativePG team. Jonathan, Gabriel, do you want to introduce yourselves?
Hi, Jonathan, you first.
Hello, I'm Jonathan, one of the CloudNativePG maintainers since 2019.
Oh,
2019. Yeah, one of the one that started actually here in this same office, in the same place, 6 years ago. Wow, that is a lot of time. Well, 5 years and 10 months, 2011, because we started August 16. Yeah.
August 1st, actually. So it's almost 6 years.
Wow.
It's almost 6 years. Yeah, we keep that in mind.
Yeah.
Gabriel.
I'm Gabriele Bartolini. I'm, also like Jonathan, one of the founders of this project. I'm also a Postgres contributor, and I've been working with Postgres many years, and I'm really happy now to, have Postgres work and run in Kubernetes. So
that's awesome. That's great, and it speaks to the legitimacy of the project, right? When you can start something and it catches people's attention and it can last for this long amount of time, right? The fact that you've been working on it for these, what you almost said, 6 years or so, and so it's obviously resonated with the community enough to keep at it and to keep going with it. So that's got to be fun.
So actually, the idea we started 6 years ago. So that on August 1st, we started what we call the CloudNative Initiative. And then the project is actually being open sourced for 3 years now.
Okay.
We open sourced it during KubeCon Valencia, I think. Yes.
May 2022.
May 22. Yeah.
Very nice. Very nice. So just to let everybody know, in case you're new to vCluster Fridays, vCluster Fridays is an opportunity for us to talk to different projects in the CNCF community. What we're going to do is we'll chat with the maintainers, see how the project is going, how it started, kind of get some history around it. And then we're going to take that project and actually try to integrate it and use it with vCluster and to go through the process of setting it up. And so that's kind of the format of the show that we're going to go through today. So you guys mentioned that you launched it at KubeCon Valencia. Was it like a big splashy launch? Did you get a lot of buzz right out of the gate, or was it kind of like a slow build, sort of like as far as interest?
Whoa, Valencia, that was May 16 to 20. That's actually the first time after COVID that we met. Remember?
Yes.
We met in the computer science something in Valencia. But it wasn't that big. We just throw it out like we started the project and say we started.
We basically open sourced it, and then we did kind of an announcement. I think what happened was that the Google Kubernetes podcast, they actually mentioned that on that day that there was a new operator for Postgres, CloudNativePG, and that's also what caused many people to come and stop by the booth and asking us for information. That's how it went, But yeah.
It was the first time we created the stickers, actually, for the launch. And when I started walking around the KubeCon in Valencia with the do you want to talk about Kubernetes? Postgres on Kubernetes. I still have that paper, actually.
Exactly. That's embarrassing, John.
But actually working. A lot of people arrive and say, okay, so you are actually talking about having Postgres running on Kubernetes, and we presented the project of CloudNativePG. That was, we started. It was actually was version 0.1 something or something like that. It was just at the beginning.
Yeah.
No, we
didn't
have the version 0.1.
No, 1.0 we were already. 1.15 when we open source.
1.0, see. Right, I moved the one from one place to another.
And just in case folks aren't familiar with your project, explain what CloudNativePG is. Essentially, it's Postgres on Kubernetes is what I think of, but like, tell me what it is and the problem that it's solving.
Do you want me to go or you go?
Okay, let me start this one.
Yeah.
You know, the first problem that you have is Postgres on Kubernetes. The first problem is Postgres. Okay, so one of the first things when you start, I started using Postgres in the version 6.9, 7.0, time ago. The first problem is configuring Postgres. That is the first issue. And most of the people, well, I'm talking about many years ago, but still nowadays, a lot of people have issues configuring Postgres and they found it really, really complicated to work with because Postgres has his style is so sometimes it could be different managing the configuration. You have a lot of extensions in the world that actually do a lot of things and beautiful things. Nowadays you have PG Vector, obviously, that is actually one of the most famous one. But before that, it was PostGIS to do all this key allocation and stuff. And that was a whole world just Postgres in that sense. Yeah, it's you can say Gabriela has been around for
not say
years, but many times.
Right.
Dealing with Postgres, and now you have the other side. That 10 years ago we started with this Kubernetes stuff that was released by Google, and all these utilities and how you start creating applications really fast, and all this container world you can use and create stuff, but you're still having one issue: it's the stateless information, and you need basically where are you going to put your data? And they started having this API for the databases. And anyway, you are connecting to a database outside your cluster, which is adding latency, obviously, because it's not working. They're going out. And probably that out means you are going to an RDS that is really, really far, or probably in another, availability zone in the same data center, but it's 100 meters away. So it's latency. By the end of the day. And Kubernetes was actually having a couple of already operators running. If I remember correctly, at that time, it was the Zalando one, which is actually was pretty famous.
Crunchy was the first.
True. Crunchy was the first. Zalando with Patroni, and then was Zalando, then was Stagres. That was running. Actually, Stagres, I remember perfectly because they, it was really curious. When we started in 2019, they gave the first a talk about the Stagres in the first PG day in Chile, in Santiago, in 2019, October 13 or 16, I don't remember, but around that week. When I was actually arriving from Italy and starting the project CloudNativePG with Gabriel and all the guys here in the office. So yeah, that is like the initial story was everything started like making it easy to configure Postgres and using it inside Kubernetes. And it sounded like crazy because when we were talking with Leonardo, and at that time he was doing all this and we were designing everything. It was like, okay, can I set up a cluster with 3 lines of YAML? Is that even possible? Well, it turns out it was possible. So
also, I think, you mentioned the other operators. I think the most important thing, I would like to actually do a step back, because it's not about the technology. It's about the problems and the reasons why we actually went down that path. And it's we have a DevOps kind of background, and we have been managing Postgres from bare metal manually down, managing with Ansible, Puppet, and so on, but we never adopted basically automated day 2 operations for failovers outside Kubernetes. Okay, in VMs or bare metal. When I was also leading the infrastructure at Second Quadrant, a company I was working before, the failover was manual because of basically networking being managed by an authority that was higher than the database. So you need to change network and DNS or things like that. And if something goes wrong, basically you might be stuck in the middle. With Kubernetes, we immediately saw the possibility to not only tackle day 2 operations, but also hopefully increase the velocity of application development when the database can actually be part of the application pipelines. So what we call the microservice database, so that you develop a feature for your application, you change the table or you add some columns, and you can take advantage of transactional DDL for Postgres, so that if there's a problem, your entire change is rolled back. So basically, the database can fit there. So what we did was we approached a fail fast experiment, and we tried and ran Postgres on bare metal and Postgres on Kubernetes on bare metal, and we saw that the penalty was negligible. So that's what we basically gave us the confidence to go full speed. And we decided to take a completely different approach from the others. So all the other operators are using tools that exist outside Postgres for managing failover and the cluster. And we decided that it was worth putting that logic into a controller and tell Kubernetes how we wanted to manage a Postgres cluster. So that's the first thing. The other thing was that we didn't adopt stateful sets, and we actually manage persistent volume claims directly. So that's the other, I think, fundamentally different approach we took from day one. That's why we started a new operator instead of joining an existing one, because it was fundamentally different.
Yeah.
So, but yeah, I would say day two operations, all operators do, but in a Kubernetes native approach to a database operator that is focused on the Kubernetes API, declarative configuration, observability from day zero, and also security by default. Yes.
So it sounds like you're essentially bringing the configuration of Postgres into the place where admins already are, right? They're already working in Kubernetes, right? So it's like, let's bring it all together so we're configuring it in one place. Yeah, that makes a lot of sense.
Well, we used to say we tried to bring Postgres to Kubernetes people instead of bringing Kubernetes to Postgres people, which is what we did. We defined the other approaches. So our operator indeed resonates a lot with Kubernetes people and less with Postgres DBAs. Okay, because maybe Postgres DBA is more familiar with tools. Patroni is a great tool.
Yeah.
Okay, so they feel more confident and more comfortable in that, instead of maybe it's a bigger leap of faith, to manage it. Let Kubernetes manage your database, okay, automatically.
Right. If you already started there, right? If I already started managing Postgres databases, I would want to use the tools I was already familiar with, rather than saying, oh, now I need to learn Kubernetes just to manage this database. But if I already was managing the rest of my infrastructure with Kubernetes, then it's like, oh, then I can just slide this right in.
But, it's not that we improvised ourselves. We've done a lot of evolution in Postgres. I think the team I was working with previously, but also now IDDB, we've developed a lot of stuff for Postgres. So we developed, for example, our team developed probably one of the first backup tools, enterprise backup tools for Postgres, called Barman. It's open source. It's very, very popular. Okay, and also we've been working with, our dear Simon Riggs, who passed away last year, on most of the streaming replication features that he was writing. So we helped with testing and like hot standby and so on. So we've been developing and managing all these features in production for many years. So we had the experience, and we decided to bring all that skills and expertise inside an operator in a programmable way, essentially.
Very cool.
There's still a lot of stuff to do, but right now I think I would never go back to VMs or bare metal. There's no, it's already better than those environments.
And that's what's resonated with your users. It's the fact that it's easy. It makes it so that they can just keep moving with their day and just bring everything into the same spot.
Yeah.
Yeah. Very cool. Very cool. All right. So what I want to do, oh, we lost Jonathan. What I want to do now actually is I want to dive into CloudNativePG and see if we can install it into a vCluster. And so vCluster, in case folks are new to the show or to the product itself, we essentially are a multi-tenancy tool that allows you to create clusters inside of clusters, inside of essentially you can create a Kubernetes cluster inside of a pod. So you have your own control plane, which allows you to have your own API server and your own data store, and you have your CRDs that you can share across virtual clusters. Freudian slip there. And so essentially what we're going to do now is we're going to create a vCluster and then add a CloudNativePG to that. Let me share my screen. Get this down here. And do this. Oh no. Okay, good. All right. So folks, let me know if that resolution needs to get bigger. I bet I need to make that a bit bigger. But folks in the chat, in the comments, let us know if you can't see what I'm doing here. What I have here is I'm in my, let's see, kubectx. I just want to show that I'm in my Minikube here. And so inside my Minikube, I'm going to create a vCluster. We'll call it CNPG. Namespace CNPG. And I think that's going to be it. I'm going to let that create. And so it's going to create a cluster inside of a pod here. While it's doing that, I want to, all right. So the best way to get started with CloudNativePG is you all tell me, actually. I'm here on the CloudNativePG site. Where should I go?
Documentation.
Right to the documentation. All right. So documentation, is there like a quick start guide? Oh yeah, there you go.
No, current latest stable version. Okay, yeah. I don't know.
Yeah, the quick start guide should actually work.
Should actually work? Okay, cool.
Yeah.
All right. So we'll get that there. Font size is good. Thank you, Floor. Great. So get that there. In fact, let's see if I can do this in the side. Come on, Mac. There we go. And then we'll come over here to there we go. Get that sideways. See if that doesn't look great, but we'll fix this. Okay, so my vCluster is created. Now, when I look at my pod or my let's say, okay, get namespaces, right? I just have a super basic cluster that has just core DNS, kubedns installed, essentially, and then essentially I have my own control plane. So it's sitting inside of my Minikube that's separated out from all the other virtual clusters that are running inside of my Minikube here. So in here, what we can do is I'm going to set up local Kubernetes playground, look it on Minikube. Great.
Yeah, you can skip this part because this is Minikube and kind install
CloudNativePG.
Right. So I want to come down here to this spot, right?
Yeah.
Yeah.
Okay. So installation section. I'm assuming it's like a Helm chart, right? Like I would just like do a.
There's multiple ways.
Okay. What's the way you recommend?
I would just click on installation and deploy.
Okay.
Yep. Lasers over. Okay. Yep. Kubernetes apply server side. Yep.
Okay. So as follows.
I
want this one. Okay. Okay. So take this.
Go back. Sorry. Yeah. Okay. Copy
this one here.
Command. Yep.
Okay. This is essentially the latest operator manifest that I clicked into here, right? Because if I look at that link, they're pretty much the same. So I'll come here.
You don't have the button to copy on the right?
No, not on that website. Not.
Okay.
So I mean, if we improve
yeah, because this is the documentation. Yeah, we need to improve that someday.
So there are other ways to deploy, like mchat or OLM, or through the plugin. Actually, we should also install the plugin.
Yeah. Actually, what you are deploying the operator, probably you can go back and install the plugin. Also, it will be really useful.
So also get the plugin. So this here, which is exactly what your page is saying. So that's good. So I come in here and get the CMPG plugin for kubectl. So this one here.
Yeah, that's the alternate way to deploy. Now that will install the operator, for example, in a different namespace. I would not use it, but click on refer to CMPG plugin.
Oh, this one here.
Yeah.
Okay.
And you can. This is how you can. No, sorry. Yeah.
No, it's okay. You should be
go up. Yeah.
Yeah. Is it too big? Maybe if I make it just a little smaller.
Yeah, because I'm used to have the scroll
the menu on the left.
Yes.
Oh, okay. Here, how about I do this?
Okay, good. Yeah.
Yeah, that makes things better.
So if you go up, there's
install. Here we go. And then installation script. No.
So I don't know if you use Crew or what. Do you use Crew or do you have Homebrew installed?
I have Homebrew, yeah.
So if you using Homebrew.
Okay.
So you brew install kubectl. I mean, yeah, there are the instructions there.
Right.
If you scroll down.
Oh yeah, I see RPG. There we go. Crew, got it.
Homebrew.
Oh, kubectl. There we go. kubectl CNPG. I think I already had kubectl. Well, okay. kubectl CNPG.
Yeah.
Okay. Okay. Let that go for a second. And so what is this installing? What is this going to give me the ability to do?
It's our command line in the interface. So basically, instead of creating a tool, a binary that you need to run to for example, work imperatively with the cluster.
Okay.
You use basically kubectl as the command line interface. So if you type kubectl space CMPG, you activate our plugin. So if you type so if you go up, there are all the commands.
Yeah. Wow. Okay.
Okay. So
all right, what's next?
So let's go back to the quick start.
Okay.
Thing. Actually, you know what, Jonathan? We could have shown the CMPG playground as well. I mean, that's for later. At the end, Scott, write a note. We need to tell you about the playground.
Okay.
So go back to the quick start.
Quick start up here.
At the top.
Right there.
So
deploy.
Now we have installed that. Now we can deploy a cluster.
Deploy a cluster. Okay.
So this is a very basic, what Jonathan was saying before, how can we deploy a cluster with just 3 lines? There are 4 because one is empty, but one says instances 3, and then storage, it's basically we are using one volume for the storage of 1 gigabyte. We follow convention of a configuration. So you don't need to specify every parameter, but by default, we made some default decisions. This will create a cluster called cluster example in the default namespace.
Okay.
With 3 instances. It means that there's 1 primary and 2 standbys. And in each instance, there will be a single volume of 1 storage with the default storage class. Okay, so if you want, you can copy that YAML file and then apply.
And apply that. Okay, so here, what I'll do is I'm going to go put this in a
will be your first CloudNativePG cluster.
I'm gonna put this in a spot where I can make sense. CloudNativePG.
Actually, we skipped one important part, that is verify that the operator is already running.
Yes.
Oh. Okay. How do I verify it's running?
It is actually on the documentation.
So kubectl get all or something.
Oh, yeah, you could do get pods -a uppercase A, but Jonathan is right.
Yeah, and it's running.
If you go back to the docs, there's the.
Got that running.
Yeah, so that's the operator. Okay.
Okay.
Yeah, if you click on the cluster example.yaml,
this one here.
See,
nice.
You will have the file, so you can actually download, and you don't need to copy and paste.
Yeah, but there's a mistake. There's a bug there. You need to remove the image name. It's been fixed. Okay. So
take this out.
Yeah, you take that out. Yeah.
Okay. I'll take it out after I paste it. So I'll take it here. I'm in here. So let's do this CMPG cluster.
Okay. And call it Scott. Let's call it Scott. The name.
Okay. The name here.
Yes.
Scott.
What if we do something fun, like testing the PostgreSQL beta?
Oh, that's a very good idea. We just did it today.
I like
so Postgres 18 will be out in 2 months. Okay.
Okay. So I should add something to this file.
You need to add the image name. Yes.
Okay. Oh, so I do need the image name.
Yes.
Oh, I thought you said I did not. So just not this image name.
Exactly.
Okay.
I'll tell you which image. Actually, I mean, you should just put Postgres 18, right? Or 18.
Yeah, 18. 18 should be enough.
18. So this same line, just replace 13 with 18.
I'm confirming.
Like that?
Okay. Let me just confirm, because we actually did it. It's something really, really, really new. Try beta 1 or beta 2. No, beta 2.
Beta 2. Beta 2. Today we do beta 2.
Like that?
Without the dash.
Without the dash. Like that.
So basically, you are going to test a PostgreSQL version that was released yesterday.
Oh, this will be
actually
fun.
This last 24 hours ago.
Okay.
Hopefully it will work. Fingers crossed.
Yes.
All right. So we're gonna run this. Okay.
You know that if it doesn't work, you're fired, John.
I'm pretty confident it will.
Cannot be handled as a cluster, strict decode, unknown field, made an image name. Did I put the?
Oh yeah, I think it's in
wrong
the spec. You need to put it in the spec.
Oh, in the spec. My bad.
Yeah.
Okay. I forgot how to.
DD.
Yeah.
P.
Nice. Thank you. Order doesn't matter, right? Just as long as it's in spec.
Yes, exactly.
Right. Okay.
No, it needs to be the beta 1.
Cannot be beta 1?
2. Yeah, because Debian hasn't released the packages yet.
Okay.
So beta 1.
Okay.
Beta 2 will be available probably tomorrow, because I think that actually Mac is still working on that.
Ta-da!
Okay, now you type kubectl get pods dash w.
W?
No, lowercase w.
Okay.
Yep, that's it.
Okay,
so it's initializing.
You want to talk about that, Jonathan, or?
Yeah, this is one of, okay, this is going to be really fast. Initializing is actually triggering what the job say, the pod says initdb. One of the things that when you create a PostgreSQL database instance, or database, how you want to call, is trigger the initdb process, okay? And then you can, after the initdb, you start your PostgreSQL. That's how you can see it. It's like the first pod is the initdb, then you create the pod number 1 is running, spending, running. It's actually triggering Postgres, And the second one is doing exactly that, is joining a replica to the cluster, and then it's up. And then the third one, and that's how you can see it. A lot of people usually they see like why is creating a job with this is, well, when you are doing manually this process is actually what you're doing. It's describing what you're doing. You cannot do that all in that one pod because you will be avoiding the order that you should follow properly.
Yeah.
And join will internally use PG base, so that's done. So it took 92 seconds. Okay.
Wow, that's great.
We've got 3 replica. So now I think we should look at the plugin. So if you type kubectl CMPG status Scott.
Like that?
Yeah. So that's a very
It works.
Wow.
command that actually gives you an overview of course, I mean, you need to have a Kubernetes administration privileges to run this, okay? Because it actually uses exec internally, right, Jonathan, to it basically. So anyway, this is a very good interface because it gives you the name, I mean, the version of Postgres, which one is the primary, when it was created, and so on. Also the replication information.
See if I can.
Actually, if you add a -b, you will get more verbose output of everything, and you can actually get it also in JSON format if you want to like parse information and everything.
Yeah.
And usually, what you are seeing here, when you are new to Postgres, all this information will not make sense at the beginning, but after, for example, if you do this, can you force delete the pod number 3?
Delete pod number 3?
Yeah.
Okay.
kubectl delete pod number, it's got 3 -- force. No, actually,
kubectl delete. So basically, you've got 3. So the way it works, it's different also from stateful sets. Okay, this is. So what happens is that with CloudNativePG, it's the PVC that leads. Okay.
Trigger the status. Well, that was way too fast.
Okay.
Can you delete pod, comma, PVC?
Which one?
Pod, at the comma, PVC.
Oh, commas, PVC?
See, look, they're in the same line.
Why don't we could show the destroy command of the plugin.
See, that is actually a good idea. Why not?
So with the plugin?
So basically, what you saw now, if we delete the pod, basically CloudNativePG sees that the PVC is still there, so it will restart the pod. Okay, but if you actually destroy also the PVC, what happens is that CloudNativePG will create the 4th instance. Okay.
Yeah. kubectl CMPG destroy.
PVC?
CMPG, no, kubectl
CMPG destroy.
Scott
-3.
I think it's Scott space 3, I think, if I remember.
This one, right?
Yeah.
Destroy, there's a typo. Oh, type CMPG destroy and hit enter to see the.
Did you mean destroy?
Oh, thank you. Thank you. The story. I'm good. It's always typing in front of other people, right? It doesn't matter if it's 1 or 100. It's Anyway, destroy Scott -3. Right?
And I think you need to put.
Trigger. If it doesn't work, put the space. Go.
Oh, okay.
Yeah, you need the cluster name, and then Scott. So if you scroll up, there should be the actual synopsis.
Right.
Yes, there you are.
Cluster instance. So I was right.
Oh, cluster and destroy cluster instance.
Yes.
Okay.
So Scott space 3.
Got it. Okay.
And then you type kubectl get pods.
The status is more fun.
The status.
Yeah.
Okay. Status here.
Yep.
Oh, gone.
Exactly.
Man.
Now go a little bit up.
Oh, I
there
see.
You are.
Yeah.
So actually, the status is telling you that we want 3 instances, but we have ready only 2. It's telling you the timelines and all the information. Now you should have probably creating the other pod already. If you trigger the status, you should see some information there. You should trigger the status again.
Okay. Sorry, I was too busy reading. There we go. Oh.
Yeah, well, it's way too fast.
Because we told it to have 3, so it's gonna constantly put a new one in.
Because we destroyed the PVC. If you didn't destroy the PVC, it will try and restart because there's already a PVC.
Mm-hmm.
So CloudNativePG will try and restart the pod.
Yeah.
With that volume.
Yeah. Okay. Oh, I see.
Yeah. Usually people say, why I don't have 1, 2, 3 because it triggers my OCD and everything. But when you're thinking, for example, why it was destroyed, and you need to start looking at the logs. You need to look for the log that is say Scott-3 in all the logs in your system.
Mm-hmm.
But if you create again a new one with the same name, how do you know when is the new one that actually works and when is the destroyed one? It's really crazy how you're trying to navigate the logs. And nowadays that we have a lot of aggregators, it's better to look for just one name in all the logs at once. It's better.
And thinking about logs, that's probably one of my favorite features in the plugin. So if you type kubectl CMPG, so I mean logs is, no, actually remove CMPG.
Okay.
How do you get the logs from a class? Okay, I mean in production, of course, all the logs will be funneled, in your log centralized log managed solution. So it's not a problem. If we want to understand what's happening, and also we do this when we train people on CloudNativePG. So kubectl logs Scott1. Okay, this is the typical, because CloudNativePG spits the logs in JSON format in the standard output, so that they are immediately caught by the container. So it's already a mess to understand what's happening here in one instance. Think about a failover. You need to understand what's happening in chronological order in the cluster. So you need to look at the logs in all 3 instances at the same time.
Mm-hmm.
So the plugin, we've developed this tool, this command called kubectl CMPG logs. Then you type cluster. So because we want the logs of the cluster, there's also the logs of the operator, for example. And you type Scott, the name of the cluster. Okay.
Right.
So what's happening now is all the logs are still, cannot understand anything here.
Right.
But you see that you've got the logs from all the instances. You see
Scott. So I see
Scott
2.
Exactly.
Yeah.
So still, we haven't solved our problem.
Okay.
Because it's still, you cannot understand anything. But if you type -f, for example, you can follow the log. And then put a pipe there.
Oh.
So yeah, you quit.
Yep.
Control C.
There you go.
Then pipe kubectl CMPG logs pretty. Yep. Hit enter.
Oh yeah.
So here you've got all the logs in chronological order from that are coming from the cluster.
Very nice.
So that's actually the container that.
Yeah, one of the things here that is actually interesting that you can actually enjoy and will understand more how Postgres works under the hood if you have this streaming and you destroy one of the replicas.
So this, okay.
Open a new. Actually, I mean, we don't need to. I mean, you just kill the replica, and then we can kill the primary. Why don't we kill the primary?
So kill the primary?
Yes. What do you think, Jonathan?
So do the destroy bit?
Go ahead. Yeah.
Destroy the primary and trigger the logs immediately. You will see some fun happening there.
Okay, so I would think the way I kill it is to do that destroy command, but you said that if I don't.
No. The delete one. No, do the delete. Start the delete pod. Yeah, delete pod, and then maybe you can even destroy. I mean, it's the same thing. I mean, what changes is what happens afterwards.
Basically, it's the same thing. Under the hood, the plugin will trigger the delete of the object first and delete the PVCs with the destroy.
Yeah, kubectl. Okay.
I forgot what namespace I put it in. Oh, it's just in default. Got it. Okay. It's got one.
Delete pod, comma, PVC.
Even the PVC you want to delete.
Yeah.
Let's do it hard. Yeah.
Comma
PVC.
Comma PVC?
Yeah. No. Pod, comma.
Delete pod. Oh, no. Okay. Yeah, that's okay. We do it after.
Sorry.
That's okay.
Okay.
The logs. Maybe go up in the history because it's that long command with pretty.
Where did they go? There we go.
No, you lost it.
Wait, where'd it go? No. Oh, there it is.
There you are.
There it is. Wow, that was weird. I am using Ghosty, which has been buggy for me. Okay.
Go ahead. Yay.
So here it's already restarted.
Yeah, it already restarted.
As a replica. So go up, scroll up.
Okay. So scroll up, you said?
A couple of lines. Yeah. Hold on.
No. This is already Jonathan. It needs to go.
Yeah, it's the rewind. It was really, it was fast. Way too fast.
No. Do you have the history, Scott? You still have the.
I do.
Yeah, if you can scroll up.
Let's see. What am I looking for?
No. Can't you go up in the log?
Terminal.
Oh.
In the terminal.
Like this?
Yes.
Yeah.
Yes.
You should find the first failure in. Oh no, it's gone.
Now go down. No, you will find it. Patience. Go down. Go down. Keep going.
Okay.
There you go. There is a starting point when it was 36 minutes ago. Go to the minute 16:42 or 41 in the timeline. Yeah.
16:42:41.
So go down. The time is the time. Go down. Yeah, the 16:36. Go down.
40,
go down.
I see. 40,
this is okay. Now it's 42. This is when the magic is actually hold a little bit. Look in the time 16:42 44.304. Go down a little bit. You will see that the instance Scott 2 is marking himself, setting myself as primary.
Oh, I'm the target primary. Wait for because the primary is gone. It's like, all right, I'll take responsibility.
Yeah, it is promoted because it's actually the one that is ahead in the world files, is aligned, it is in order, the first one. So it is there.
Nice.
So and then say it's promoting the instance. So the operator say okay, I lost my primary, need to select a new one and say, okay, number 2, you are the primary, do your job.
Oh yeah, that's why we mean Scott 1, because when we ran the logs command, the pod was down.
Mm-hmm.
Yeah.
So exactly. That's why we needed to keep one terminal with the logs on. Okay. So that's why we got only the promotion. Okay, here. But
there is still a lot of information here that is very interesting. So if you go down, you will see that the insert manager is okay. Now the number 2 is promoting. And there is some, wait a second, go a little bit up.
Okay.
A little bit up, okay. And then it's actually align it and say, okay, I'm going to start with a new timeline ID, the number 2, which is important to keep in mind. Because when we see the status, this will be important. And checkpoint starting, it's ready for accept connections, and everything happened in 1 second, less than a second. That is the beautiful part. Because if you see 42.
Yeah.
Scott 1 comes back up.
And Scott 1, yeah, it does come back right
then
here.
It said, okay, look, if you scroll down, I'm a primary.
Yeah, but hold on. Now, a little bit up, you will see that the actually Scott number 4 now is getting the timeline number 2 from Scott number 2.
Yeah. So the other replica is already attached to the new primary. And then when Scott 1 comes back up, if you scroll down, you'll see that we check how it was shut down. So what the system thinks. So the directory, the Postgres directory tells that this was, when it was shut down, it was a primary. So if you scroll down, yep, see, this is an old primary. So basically we demote that.
Yeah.
So it actually demotes itself. That's the other thing of CloudNativePG, because the instance manager is kind of what we say the right arm of the controller, is the PID1 of the Postgres process. So nothing runs inside a container if the instance manager and the operator don't agree. Okay, that's why it's, if there's communication between the API server and the instance manager, there's no way you can have a split brain, for example.
Right.
Okay.
Right.
So so it was demoted, and now it is, once it reaches consistency, it starts as a host standby, and it will start being available for read operations.
Actually, you can trigger the status again, and you will see the new timelines and how they follow, who is the primary again.
No, the status command.
Oh, sorry, status. My bad.
Yes.
Bonk.
If you add another V, you can actually see. You can actually see Postgres configuration options. So add another V.
Like that?
Yep. So if you go up, you should see also, go up. So this is the Postgres. Okay, these are Postgres GUCs or parameters. Okay.
Nice.
So this is, as you can see, there's TLS already by default. So this is very important when we say we've got a security by default approach. So the operator by default, without you can specify your certificates. You can bring your own certificates, but by default, the operator has got its own CA. And every time a new cluster it is created, if you don't specify anything, a new CA for that cluster is created, and so basically certificates are generated automatically by the operator. So all the communication between by default, basically all the communication happens via TLS. So theoretically, we can also support MTLS if your client certificates are generated using the same CA. So this is cool. I mean, and by default, the operator doesn't allow any super user connection. It runs as a standard user in the container, but also by default, all the Postgres super user commands need to go basically through the CRD. So if you want to connect as Postgres, you cannot by default.
Not by default.
Yeah. So you need to request super user access, which we discourage. So of course, there are some things that still the operator does not provide you with through the API. So you need to, for example, go through an imperative way. Okay, so you need to enable super user access and then perform the operations and then disable that. But we're working on that. It's actually a project that we started. So CloudNativePG participated for the first time in the Linux Foundation Mentorship Program. So we've got actually a student, a mentee. She's writing support for foreign data wrappers that require actually super user privileges to create and manipulate. So she's integrating that support into the database CRD, which we have. So that, we over time will basically enable to control all the resources that in the database require super user privileges through CRDs. And I want to say hello to Ying. She's our mentee, and she's doing a great job with the mentorship.
Nice. So from a developer's perspective, because my background before I got into all this fun Kubernetes as a developer, how would I start? How would you hand this configuration over so that I could start building a schema and things like that?
Yeah, that's a good thing. So we've got a command that so if you type kubectl cmpg psql and Scott -- app.
Okay.
Yeah.
That's
I think you need a space before app, but
like that.
Yep. That will basically allow you to connect as Postgres user via the container to the app database.
Nice.
So by default, CloudNativePG creates an application user called app and a database called app owned by the app user. So if you type backslash, not the other one, sorry.
Oh, yeah.
D.
Which one?
Yep.
D?
Yep. Sorry, backslash L. Sorry.
Yeah.
Okay. So
I started on Postgres, but it's been a few years.
These are the databases available. You see that there's Postgres, which is used for by the operator to coordinate all the work, and the app user, which is what we call the microservice database. So by default, you can connect your applications via the service using those credentials.
Very nice.
So this is, I think, what we need to show, Jonathan. I think we need to show the services.
Get the secrets first.
And the secrets.
Get the secrets. The secrets first is the first part.
Yeah.
kubectl get secrets.
Okay.
So dash. So yeah, exit or
Yep.
Yeah. So what you can do here, yes, is kubectl get secrets.
Get the Scott-app secret and get the YAML. Get secret Scott-app space -o YAML.
Oh, YAML, right.
If you go up a little bit, you will see something that is actually all this. This started like actually one line, 2 lines, user and password. Now it has a lot of information. If you check, for example, the field URI. No, the about.
Oh, right. Sorry.
URI.
Right there.
If you decrypt that base 64, you will see a lot of beautiful information in that string that allows you to connect directly to the PostgreSQL information. So can you copy the string?
In there.
That one. Echo to the string. Pipe base 64. Base 64 space -d. Okay.
Oh, wow. Perfect.
So that will actually is going to show you basically the string you're required to connect. So if, for example, if you have your app and everything, you will say, okay, can I get this the access to the secret with the information to connect? Here is the information. PostgreSQL the username, semicolon, password, add the service, which is going to talk a little bit, the port / the database. This is like really standard for Postgres, but there's another one there that is the JDBC, which is to connect all the kinds of apps and everything. That's why we have user and username. There is the PG pass, which is actually a PostgreSQL, the format for a PostgreSQL file that you can add to your home or your environment to support libraries. PostgreSQL libraries knows how to connect to Postgres really quick. And it's a standard. So you just copy and paste locally and that's it.
Yeah.
Get the services now.
Okay.
kubectl get services. And this part is the fun part. You will see that you have the Scott RW, which is the one you see in the URI to connect above, and the read only RO. Guess what? RWS read and write. RO is read only.
Very cool.
Yeah. So those services, obviously, you started your application basically from the beginning, thinking on Kubernetes, on being that you can grow. You will have queries to the read-only service and queries to the read-write service. So you can split using those two services at the same time. And under the hood, you will be connected to replicas or primary, and that's good. Now, there's another service there, -R, that probably we will deprecate in one or two versions.
That's useful. That's still useful. It's random. So if you have the prime, I mean, there's already the possibility to disable that.
Yeah.
So there's some conflict between maintainers, as you can see.
But sometimes you can actually want to connect some randomly servers, like really random, because it will give it by the Kubernetes service. You will use that one. But basically, RW and RO is the services that you will always use because it's defined by itself.
Yeah. And you can create a load balancer type, for example. It's if you want to connect directly from outside Kubernetes. So there's actually a lot of users that run CloudNativePG for their database, internal or external database as a service solutions. I think you should look at the endpoint.
Yeah, that is the other thing.
Get endpoint Scott. Basically adjust all the endpoints.
Yeah, good.
Without Scott, sorry, without Scott. Endpoints. Yeah, that's it. So you see, there's only one prime.
Yeah.
You can understand better which one is which one.
So if there's a failover, your applications don't need to change the connection string. Okay.
Yeah.
They don't care which one. That's why also we don't care if it's Scott 4, Scott 5. People say, why it's not Scott 3? Hang on. I mean, isn't these cattle versus pets? I mean, now you complain that it's not anymore Scott 3. Why should you care if it's called Scott 4 or Scott 5?
You should not care at what is the name of the pod, because you should connect always to the service.
Right.
Not the pod.
Anyway, so this is very important, because if there's a failover in that moment, you don't have any endpoint to the RW service. Okay. And so anyway.
That's great. No, that makes a lot of sense, because now you're essentially, you're forcing folks or encouraging folks. This is how you should do it. You connect to these services. It's like, and then rather than trying to fiddling with all the permissions, it's like, this is read only, this is read write. Here are the endpoints.
Exactly. And then also you can use external secrets, for example, to let it handle the password. So you don't even have. So passwords could also be stored somewhere if your application is outside Kubernetes. In a KMS.
Yeah. Can you go to the documentation?
Okay.
In the documentation, we have a section on the left.
Yeah, at the bottom.
That is down, actually, at the bottom.
At the bottom. Okay.
Yeah. It's CNCF Praise integration. The first one is external secrets. This was born in London.
Yes, at the Maintainers Summit. We met Gustavo, one of the maintainers.
Yeah.
founders of the project. So if you scroll down, we actually provide a recipe to get external secrets, update the password, in this case once a day, I think every 24 hours.
Yeah.
So that if your applications are in the same namespace of the database as we encourage for the microservice database, basically the secret is continuously updated by external secrets, and applications basically don't have to change anything. Okay, so
nice.
So the main idea here, well, actually, the crazy idea here that when we were talking with Gustavo was, okay, one of the issues is that you can expose your PostgreSQL password to the world in the web app, okay? But what if that password you use once is valid for only 1 minute? Since you are already connected, you don't need to reconnect. The password you connect, you do all your work, you can expose your password, but the password is not valid anymore after 1 minute. And if you're going to connect again, you request the password to the secret again, and you connect, and your password has changed again. So if you do it like that, you don't care if the password is actually something that, like in the past, in the past when someone filtered the password of the database was actually really, really dangerous, because you need to change the password. When you change the password, you need to go to all the apps that are using this password to access this database, and go to the process of refreshing the password, register the incident. But if the password, the time to live of the password is just 1 minute and it's defined like that, this will make your application secure by default, because your password is commodity.
I think 24 hours is already good. I think, or 5 hours, 8 hours. But yeah,
but this started with 30 seconds.
Yeah. Wow.
The original idea was 30 seconds.
This is something that we want to emphasize for the next year. I mean, we're trying to get into incubation. So our approach is, we will not stop, of course, developing new features. Okay. But the idea is, we prefer to slow down, but, for example, work to enlarge the community, work to integrate more broadly with our brothers and sisters projects in the CNCF. The first one was external secrets. We're working with Kyverno, Keycloak. Cilium, you Argo CD, you're working on that, Jonathan, as well. So Schema Hero is another one. So we're trying to work with all the other, one at a time with all the other projects. And because there's one important thing in our philosophy: if there's already another project in the CNCF that is good at doing something, we don't implement. We try and integrate with that. So, for example, Kyverno is very good for security, but also for enforcing policies, so that you can create your policies for the default values, and let Kyverno, allow you to basically define very small manifests, but then Kyverno can add all the other options that your company requires without you having to specify them. So anyway,
that makes sense. That way all the projects focus on what they do best, and then you integrate well with them.
So, this is the main idea is always be interactive. For example, why we should care about the security inside of Postgres. Someone can access Postgres. Obviously, someone can access Postgres, but they can access because they have access to, and that is Kyverno or Cilium, that is allowing the network access. But how they get the password, that is external secret getting the password using some vault in the back, Amazon, Google, Azure, HashiCorp, OpenCorp, whatever. It doesn't matter, and you make it. Your entire ecosystem is already secure because the ecosystem is secure, not because one strong that make a failure. Because we do database, we don't do policies, we don't manage secrets, we do databases, and that's it. Yeah, it's
and you do them very well, right? And so, very cool way to manage Postgres inside Kubernetes.
And easy,
very easy. Yeah,
but let's not go down. I mean, we still need to understand Postgres and Kubernetes. Okay?
Sure.
So, but we didn't talk about backups, and so on. But anyway, there's a lot of monitoring, like got Grafana dashboard and so on. But anyway.
Oh, that would be great. Integrate that in with their Grafana dashboard. Then you can start seeing all their.
Yeah, we've got a Grafana dashboard as well. So
yeah, actually, if you go to the CloudNativePG in GitHub to the CNPG-playground, there's a lot of things that you can have the example how to work with 2 regions. You will have an example of the Grafana dashboard that you can see on how to use it, how to deploy it.
Actually, if you look for CNPG Playground, even in Google, I mean, if it's CNPG Playground, it's actually a very cool project.
Are we indexed?
If you want to learn, sorry?
We are indexed on Google. You didn't know that.
Yeah. So if you scroll down, this is what the environment we replicate. You can actually, do it with vCluster as well. We simulate 2 regions, Europe and US. In each cluster, we have 6 nodes. And we dedicate 3 for Postgres, which is our recommendation. So we recommend to dedicate nodes for Postgres, and then use stains, tolerations, and so on to ensure that they fall there. And then we've got a Minio object store in each area, in each region to enable you to do the backups on object stores. So if you for those who are following us, if you want to learn how to do it, you just go here and you follow the instructions, and you're able to have 1 Postgres in Europe, 1 Postgres in US in your Docker, and then demote one and promote the other one without having to reclone anything, just by using backups as well. So it's
very cool.
Okay.
Yeah, this is one of the things
you want to help us, anyone.
This is one of the things we did in the workshop in Bologna for Cloud Days Italy.
Mm-hmm.
Probably we will do in September in H-Case, I think is the name, I don't remember. And we are going to do some workshop also with CNPG. So I don't know if you're around any conference, like, where are we going to be? PG Days Lowlands, in Denmark, PG H-Case, I don't remember the name, or something like that. But everywhere we do it, we try to teach people how to use the playground, because it's actually...
I need to go.
Yeah, we need to.
Sorry.
We are really far of the day. But yeah, we can go for a long time talking about this. But this playground is amazing, and it's a really, really beautiful starting point.
That's fantastic.
Yeah.
I think it's great to have resources for folks to get to know your product and have it laid out, because that's the biggest key of adopting anything. Developers want knowledge. We want information on how to get a thing, how it's going to help us out, but how do I use it, right? Like just having no documentation, but even going the extra step of taking it and taking your documentation and then saying, here, let's have a educational like sandbox area that you can do this, and here's the instructions on how to set it up. So thank you guys. You were fantastic. Learned a lot about Cloud Native PG. Looks like a super rad product or project and product. And so thank you so much for joining us today and sharing with us about what you're working on.
No, thanks to you for the
Thank you.
It was amazing to meet you, actually.
Yeah,
same.
Same. So will you be in Atlanta, or?
I will definitely be in Atlanta. Yeah. So yeah, we'll hopefully we'll meet there as well.
Good.
In person.
Yeah, I will not be there.
No? Oh, okay. Well, then that means I'll have to come out to Italy then.
Exactly.
Yeah. Florence is outside Prato, so you can come to Prato and you will be really happy here.
Right.
Definitely.
So yeah, definitely Prato. Remember, Prato, Florence is outside Prato. So Prato is the center.
Exactly.
Florence is some city that's right outside of it. So
no one knows that city.
No, never.
By a Chilean who moved to Prato, that tells a lot. Anyway.
Right.
Okay.
Well, thank you all for joining us today and for joining our live stream. We will be back with vCluster Friday next Friday. Simon will be talking with the folks at K Gateway, and we'll be doing the same rundown where we talk through their project and then see how it works with vCluster. And so until that time, hope you all have a good weekend and a good week. And thanks again for joining us.
Thank you.
Ciao. Thank you.
Ciao.